Under this unit, we would be studying the key terminologies of production management. The main headings we would be covering under this are basic components of a production system, production strategies, and key production systems. By the end of this unit, students will be able to describe the basic components of a production system, review production strategies, describe various key production systems comprising of continuous production, mass production, batch production, and JIT, that is just in time production. Under basic components of a production system, we basically have three major points, that is the input, conversion, and output. It basically defines what is production. Any production process would involve these three, which is the input, conversion, and output. Under input, we have raw materials, which would refer to fabric or trims, etc. We also have purchase parts. Personnel would basically comprise of labor requirements. Competitive information, which refers to what your competitors are doing and what we need to do and what we need to strategize. Demographic information, to understand what the customer needs. Product information, which refers to how a product needs to be produced or what kind of product that needs to be done. Customer needs, stockholder needs, capital, which refers to the investment that is required, machinery required for a particular product, and finally, utilities. Under conversion, we have transportation, warehousing, manufacturing system and machinery, which basically gives us the owners on how a product needs to be produced and what kind of technology needs to be utilized. Policies and procedures required in setting up the conversion process. Logistics, wholesale retailing system, the physical layout of the manufacturing unit, and of course the production process. Then finally we have the output. The output refers to two major things. One is your direct output and your indirect output. Direct output refers to the tangible output, which is the end product, that is the products and the services that is going to come out of the manufacturing process. Indirect output refers to your intangible output. That includes your wages and salaries, environmental output, and the community impact. Next, we come to production strategies. This basically defines us on what strategy we need to undertake and define our production process. The three major types of strategies that are involved in making these decisions are these. First comes make to order, make to stock, and assemble to order. What is make to order? Make to order refers to those products and services that are made to the customer specifications once the order has been received. For example, make to order would basically refer to export manufacturing processes inclusive of apparel units, wherein we get the order from the buyer and we manufacture only for the particular order. Next comes make to stock. Make to stocks are those products and services that are made in anticipation of demand. Our retail manufacturing units normally adhere to make to stock, wherein pieces and garments are being made and they are stored in the retail houses, retail shops, and then sales are done. So we do it based on the anticipation of the demand and not based on customer specifications. The last process is assemble to order, wherein products and services are added based on options provided by the customer. This will include all our automobiles, wherein the customer prefers a specific color or a specific engine setup, and then they are assembled to order. We finally come to key production systems. What are key production systems? These are the various types of production systems that can be taken and incorporated in our manufacturing process. The most common systems that are used are the following. We have the continuous production, mass production, batch production, one-off production, and JIT, that is JIT production. Let's see what is continuous production. Continuous production refers to non-stop production. That is, this production happens non-stop and doesn't stop for any reason. It is irrespective of any special order that comes in and works 24/7 on the clock. Basically refers to those kind of products which are of constant supply to the customers. Various examples can be given for continuous production. Your petrochemical refining, soft drinks, distilleries, fiber production, paper manufacturing, and power plants adhere to continuous production process, wherein the production is continuous and it goes on all through the year irrespective of demand. Next comes the key features of continuous production. The first point being enormous capital investments. Highly automated facilities are required for continuous production. We need high and special end purpose equipment. High volumes of production are involved in continuous production, and typically the output is of little or no variation. The next would be your mass production. Mass production basically refers to the demand-based production on a highly large scale. It is done when the product is produced for days or weeks in large quantities. Though it does not refer the same as continuous production, wherein the production is 24 hours, 365 days a year, but this does go on for days and weeks continuously. Different workers in the production line are responsible for certain part of the product. Key examples of mass production would be garment manufacturing, yarn or fabric manufacturing, pharmaceuticals, and automobiles. The key features of mass production are standardized methods, single-use machines to produce long runs of standardized items. In this picture, we can see examples of mass production, that is the jacket making facility and the cutting part of an apparel industry. These are key examples of mass production wherein bulk quantities are made at a stretch based on customer requirement. After mass production, we would look at something called batch production. Batch. What is batch? System processes many different jobs at the same time in groups. That refers to the terminology of batch production. Companies that batch produce are usually capable of switching what they manufacture quite quickly. That is, we are referring to something called flexible manufacturing systems. Under these, the key examples would be your fabric or garment processing zones, furniture manufacturing, and food industry. Here we can see a small example of batch production. Here we can see an example of an engineering unit where we have the lathe shop, the milling section, the drilling section and the grinding section. We can see here that all the lathes are combined into a batch, and similarly milling section is combined in a batch, and so on and so forth for the drilling and grinding section. So they are quite flexible and adaptable to change, and that is what is a good example of batch production. Finally, we come to something called JIT production. What does JIT mean? JIT is basically the short form of JIT, that is just in time. Just in time production is when products are made as and when they are needed and required by the customer. Ideally, in just in time, the products arrive at the factory at exactly the same time they are needed, which saves and cuts down on warehouse costs. Many automobile units have complied now to start using JIT production. Here we can see an ideal example of JIT production, wherein there is absolutely no gap or delay in time or stocking of pieces or warehousing of any production components. The supplier processes into fabrication. From fabrication it moves on to sub-assembly. From sub-assembly it moves on to assembly. And finally it directly goes on to sales. It basically shrinks down your production time, lead time, and improves the cycle of money movement. So JIT basically refers to a balanced, synchronized, simplified, waste-free and rationalized way of production. Let's see a comparison chart on the various production processes that we've just studied. Here on the x-axis we have standardization, and on the y-axis we have volume. As you can see, continuous production has really high standardization and really high volume of quantity, which basically refers and automatically reflects. We have the continuous production where the standardization is high and so is the volume. It directly reflects the fact that the production is ongoing and does not stop for any reason, and hence you have very high standardization of machineries, of orders, etc. And similarly the volume, that is your output quantity, also is always high. Next comes your mass production, when the standardization and the volume tones down a little bit, and similarly it turns down even further for batch production. The lowest standardization and lowest volume comes to your project, that is it basically refers to your JIT production, wherein there is very low volume and there is very low standardization because everything keeps changing as per the customer demand. Now let us try and analyze and try to calculate a couple of numericals. We would be calculating efficiency of standard, etc. The example that we would be taking is of a pajama pant with a SAM value of 12.35. With the current setup of 22 operators and a daily working time of 8 hours, what should be the production of line per day so as to achieve ideally 70% as line efficiency? So like I said, the style would be the pajama pant, the SAM of 12.3 minutes value, 35 minutes value. Number of operators in the particular line which we are talking about is 22, and we need to calculate what should be the production if we need the efficiency at 70%. So as we need to calculate the production, let us see how we can do that with the current set of values. So the efficiency formula that we already know is efficiency percentage is equal to SAM. SAM is standard allowed minutes into production, that is the number of pieces produced, divided by the operator in that particular line into the time that is available. So, in this scenario, SAM would refer to 12.35 minutes. We need to calculate the production. We already have details of operator, that is 22, and we have the time, that is in a day we have 8 hours. So, when we need to calculate 8 hours in minutes, because the SAM we have given is in minutes. So, usually time taken would be 8 into 60 minutes, that is equal to 480 minutes. This is the time available. We need to calculate the production that needs to be achieved at 70% efficiency. So, we have the efficiency detail, we have the SAM detail, we need to find the production, we have the operator detail, and we have the time detail. So, when we affix the required numericals, we have 70%, that is the efficiency, 12.35, that is the SAM, into our question here being production, divided by 22, that is the number of operators, into the time, that is 8 hours into 60 minutes. When we further do the calculation, 70% is represented as 70 divided by 100, right? So, that would be calculated as 0.70. So, efficiency here taken is at 0.70 is equal to 12.35 SAM into the production, which we need to find out, divided by the calculation of this 22 into 8 into 60, that is equal to 10.560 minutes. So, when we do the calculation of production, the next step here would be, now that we have this formula set, let us try to calculate production. So, from here we need to invert everything to the left hand side. So, production is equal to 0.70 into 10,560 minutes divided by 12.35, which becomes an indivisible number. So, once we do the calculation of this, the answer we get is 598.5, that is, to achieve 70% efficiency with the current set of operators and the SAM value of the garment, we need to get 598 pieces per day so as to get 70% efficiency. Now that we have calculated that per day production needs to be 598 pieces, let us understand how long it will take to calculate the total order quantity of 15,000 pieces. So, to calculate the number of days that needs for the production of 15,000 pieces, the formula is, so to calculate the number of days required, please pay close attention to this formula which is coming on your screen. We need to divide the total order quantity by the production per day. We've already calculated the total order quantity as 15,000 pieces, which is a given data, and we've calculated the production per day at 598.5 pieces at 70% efficiency. So to calculate, we need the formula as total order quantity divided by production per day. When we substitute the numbers, it comes to 15,000 divided by 598.5. Thus, the number of days required for producing 15,000 pieces is 25.08 days. I repeat, the number of days required to produce at 70% efficiency is 25.08 days. Like I said, this is the ideal scenario where at 70% we can produce 598 pieces. Now let us take up the current state setup at day 3. At day 3, the number of operators present are 21. And the production that has been achieved on that particular day is 430 pieces. Let us also analyze and understand the off-standard data. Operator 3 had no electricity for 25 minutes in the machine. The whole line started late by 15 minutes due to bus delay. And operator 6 had consistent machine problems throughout the day for 195 minutes. Now, let's calculate the line efficiency, the on-standard time, the off-standard time, and the on-standard efficiency. As you can see, what is off-standard time? Off-standard time is that particular time due to which there is no value adding process inside the line. So, here if you look at it, this electricity delay of 25 minutes, full line delay of 15 minutes and machine problem of 195 minutes is considered as off-standard. To calculate total off-standard time, all we need to do is add up these three details. But wait, here we have mentioned that that's a total delay of 15 minutes for the full line. So this needs to be calculated as 15 into 21. Why 21? Because all the 21 operators in the line were delayed due to the bus and hence delay in start of work. So the delay of 15 minutes needs to be calculated across the line. So, if we calculate the total off standard minutes, it will be calculated as 25 minutes, that is for no electricity. This 15 into 21, the answer would be 315 minutes. So, that will also get added here. Plus another machine delay of 195 minutes. In total, the off standard adds up to 535 minutes. Now that we have calculated the off standard time, that is, we have arrived at the time 535 minutes of wastage. Let us try and calculate the on standard time. What is on standard time? It is basically the time taken where the value added processes have actually been done. So, what we need to do? We need to eliminate the off standard time from the total time. So, the formula for on standard would be total time minus off standard. That is equal to, now this off standard has been calculated for all the 21 operators present. So, the total time in 1 day per operator is 480 minutes, correct? So, the total time here would be calculated for all the operators of 21, right? The operators present on day 3 are 21 minus the off standard here being 535 minutes. If we do this calculation, the answer comes to 9545 minutes. So, the off standard time for the particular line is 9545 minutes. So, we have got the off standard, we have got the on standard. Now, we need to calculate two things. One is the line efficiency and we need to calculate the on standard efficiency. Let us first calculate the line efficiency, for which we already know the formula. So, the line efficiency here would be calculated as SAM, that is 12.35 into production. The production for that day is 430 pieces divided by the time. Here we are just calculating the line efficiency. So, the time available is 480 into operator. The number of operator present on day 3 is 21. This into 100 because we are calculating it as a percentage, right? Now, if we do this calculation, the line efficiency comes to 52.68%. Now that we have calculated line efficiency, we need to calculate something as on standard efficiency. What is on standard efficiency? See, line efficiency takes the time of the full of 480 minutes. So, in case of issues that is running, genuine issues running in the line due to which the production drops down, on standard efficiency gives us a better picture. So, whenever we talk about line efficiency, we should always mention the on standard efficiency as well. Alright. So, the formula for on standard efficiency, hold on, I am going to change right here. So, on standard line efficiency is the same. We have SAM, we have the production, we have the operator. The time here changes. So, it is on standard time That's all. There is no other change in the formula for on standard efficiency calculation. We just change the on standard time. So here everything remains the same. We've already calculated the on standard man minutes for 21 operators, which is 9545, correct, which we've just calculated in the previous set. So when we do this, the on standard efficiency comes to 55.65%. So as you can see, the on standard efficiency is higher than your line efficiency. That is because it has eliminated all the off standard time and the unwanted time, due to which the line has fallen short of the required number of pieces. Now we also need to see that the number of operators have reduced and the production has also reduced. So in the current scenario, the line has not been able to produce for the target 70% efficiency and has dropped down to 52% efficiency with a non-standard efficiency of 55.65%. Now let us look at a slightly different scenario wherein we will be calculating factory efficiency for a mixed style in the same line. Alright. So in this particular example, let's say we are talking about style A and B. Now the production for style A is 200 pieces. The SAM, that is standard allowed minutes, time taken for one garment to be produced, is 15 minutes, and the production for style B is also 200 pieces, and the SAM for this particular style is 20 minutes. You can see that there are two different styles with two different time factors, whereas the production is the same. The number of operators involved in this particular production for both the styles inclusive are 20. So how do you calculate the line efficiency here? In this case, let me put down the formula. It is the same like we always discuss for line efficiency. You have SAM into production divided by your time into operators, correct? There is just a slight variation in the formula here. So line efficiency percentage is equal to production of style A into SAM of style A plus production style B into SAM of style B divided by, we just have the complete set of operators, so it makes it easy. Total time taken into operators. In case you have a numerical wherein there are two different sets of operator for each style, All you need to do is club both the sets of operator here, which will also give you the same result. So let us try and calculate here. So if we affix according to the formula, production of style A here is 200 pieces into SAM of style A, yes, 15 minutes, plus production of style B 200 pieces into SAM of style B would be 20 divided by time taken. Generally time taken is 8 hours working in any factory. If not mentioned, it should be taken as an 8 hours working factory. So it is 480 into number of operators mentioned here are 20. So since we are calculating efficiency, by default please input into 100 because it is a percentage result. If we calculate this, we would be getting 3000, which is the calculation of 200 into 15 plus 4000, which is 200 into 20 divided by 9600 into 100. So the answer for this would be 72.9%. This is the line efficiency of a mixed style, that is style A and B. As you see, the formula is not so complicated as it sounds, and this same formula can be utilized in mixing and matching of finding various factors in a garment industry. Conclusion. You have come to the end of this unit. In this unit, you have been given an overview of different components of a production system, reviewed critical production strategies, and learnt about various key production systems. The examples that you viewed gives you an in-depth understanding of what you have learnt. Thank you.